Hi there, I'm Scott Lowe with ActualTech Media. Today I'm at YugaByte, where I'm joined by Karthik Ranganathan, who is the CTO and founder of the company. Thank you for having us in your offices.
Thanks, Scott. Thanks for being here.
So we want to talk about the architecture of YugaByte and what you're bringing to the world. And on the board here, we have a very pretty drawing. Can you tell us from the high level down what we're looking at on the board right now?
Absolutely, Scott. So when we started YugaByte, it's an open source database. So we just wanted to make sure people are able to try it, use it, and build useful applications on top of it, right? So when you're looking at modern applications, we're in the Cloud 2.0 era. Cloud 1.0 era was take your application running on-premise, just run it in the cloud. Cloud 2.0 era, everybody's thinking, how can I use the cloud? There's like 80, 90 data centers in different regions available. How can I use it? Typically, they deploy many databases side by side because each API or database really brings a different aspect to your requirement, right? So if you want transactions, for example, you always go to SQL, right? But SQL does not scale out. So when you want to scale out, you always go to something like a NoSQL system, like a Cassandra. But now that your data is in two different data stores, you can't serve it with low latency, so you go to a third data store, which is a Redis, which is used as a cache. It doesn't persist data, but it serves it very fast. So our thesis behind YugaByte is, why can we not marry these three APIs and put them on top of a common database? So we took Cassandra language, we made it wire compatible with Cassandra, so you can just run your Cassandra applications on top of YugaByte, added distributed transactions, secondary indexes, and so on and so forth. So your app can be very easily written. Similarly, we took the Redis API, made it persistent and scalable. So you don't have to worry about manual sharding, none of that stuff, right? And we took SQL, and we're working on making it a completely scale-out database underneath.
So basically, if I'm running Cassandra, Redis, and SQL today, I can rip those out, and I can put YugaByte in.
Yes.
A single product.
Absolutely. So for Cassandra and Redis, you can do that today. The SQL API is a wide API. It's in the works, and it's coming out pretty soon.
Okay. So tell us what we have here. It looks like we have 3 nodes, a typical 3-node architecture. What does this mean for our audience in the context of YugaByte?
Absolutely. Great question. So you write data through these different APIs. This data gets stored in the form of tables underneath. So YugaByte automatically splits these tables into small chunks and distributes them across 3 nodes, 4 nodes, however many nodes, right? And you don't have to make that decision up front. So what do? We, inside YugaByte, have implemented a Raft-based replication.
And what does that do for the architecture?
Right. So Raft is a consensus protocol that helps different nodes agree on a certain value. So that means you now have your data replicated across these nodes.
Consistently.
And consistently. They're in agreement, right? So that's the first bit. The second bit is, now that your data is agreed upon by different nodes, you need the node to store and serve the data efficiently, right? For that, we have a DocDB, a document-based core, which is a heavily extended and modified version of RocksDB, right? So, and that's what we have on each node. Now, on top of all this, now you have replicas and you have the ability to serve, but that still doesn't mean you will serve consistently across nodes. So in order to enable that, we have a global transaction manager. This piece makes sure that your data across nodes is like consistently served. So if a node fails and a second node comes up, you do serve the consistent value of the data. And all of this, irrespective of the API, is provided to you with auto sharding and load balancing, right? So what sharding says is, I'll keep different shards of your data across different nodes. So as you continue to add nodes, you can scale out your system. You can move these shards efficiently. And what load balancing says is, if a node dies, or you remove a node, or you add a node, you'll be able to consistently spread out your load so that your load is evenly balanced across different nodes.
Now, these are not just simple replicas of each other. Once you start to get to a certain size, there's different data in the different shards. But
absolutely.
The transaction manager understands where everything is and points the client to the right node.
Absolutely.
Okay, cool. And then so as you grow, can you determine the replication level and stuff like that, or do you always do like a 3-node?
It's configurable. Our default is 3. It allows tolerating 1 failure, but you can configure it to 5, 7, 1, however you want.
And you just add some hardware or add some instances?
Add some instances. So yeah, that brings us to, what do you run YugaByte on, right? So you can run YugaByte on bare metal, on VMs or on containers, right? So in the bare metal case, it's typically very useful for an on-premise deployment because a lot of people on-premise have bare metal machines. They want to squeeze the most performance out of it. With respect to VMs, you could do VMs on the on-premise, or you could do them in public clouds like AWS, GCP, Azure, and so on and so forth. So this makes it very easy to run YugaByte the way you consume nodes in a cloud. Or thirdly, you can run it inside containers. So you can run it inside Kubernetes, and you can run it inside a managed Kubernetes service like GKE, the Google Kubernetes Engine. So irrespective of what your IaaS layer is, it's really easy to deploy and run YugaByte at planet scale.
And what kind of applications are customers running on top of this platform?
Great question. A lot of applications. So I will start from the NoSQL spectrum all the way to the SQL spectrum, right? So you have time series applications, IoT applications. These type of applications have a lot of reads, a lot of writes, and you need to present the data to the end users. All the way on the other side is identity applications. So people logging in, logging out, so on, like your user identity, your user profile. So things like user profile and shopping cart, where you have what the person is viewing in terms of a product and its price, but you also want to do recommendations on top of the same database. And that is really easy to do because it supports a wide array of languages, and it's easy to distribute the data across the world and use like a Redis-like API to do very, very low latency queries. And
how far does this scale for customers right now?
We have tested it internally for up to like 50 nodes, so you can easily go and get, and 50 nodes like for like the type of machine we tested gives you like millions of reads and millions of writes. But we can keep going because as a team, we've built this for hundreds and hundreds of nodes at Facebook scale, where we were doing billions of reads and writes. So it's a pretty scalable architecture.
Very good. Karthik, thank you very much for this overview of the YugaByte platform.
Absolutely. Thank you. Thanks a lot.
Appreciate it.
Absolutely.